Hello students, I am Dr. Ghumare from Sanjivani College of Engineering, Kopargaon. Today we are going to discuss few important practicals of concrete technology that is important for your upcoming oral examination. You know that in concrete we are using the different materials like cement, sand, aggregate, water and various admixtures and additives. So it should have certain qualities. Okay, so to know the quality standards in India, we are following the IS codes. As you know that for OPC cement, there is IS 269 2015. For PPC cement, it is IS 1489. For aggregate, it is IS 383. For testing of hardened concrete, it is IS 516. For RCC, plain cement concrete, it is IS 456. For concrete mix design, it is IS 10262 2019. And testings on coarse aggregates, this is IS 2386. So before going for any practicals, you must know these IS codes, and we should know the procedures given in IS codes. Now, as the cement is a mixture of cement, sand, aggregate and water, so starting with cement. Okay, so cement is a binder material used in concrete to bind coarse aggregate, fine aggregate when it is water is added to complete the hydration process. So test on cement, so important test we are conducting in laboratory as well as in the field. So you know very well field test. Whenever any fresh sample coming on the side, there are few field test that cement should be greenish gray, cement should have cement should be very fine, cement should be greenish gray, cement uh, should have certain color, cement should not have any sort of lumps in the bag, sample should be very fresh. You should check tag of the bag and see when sample is manufactured. So like this there are various field tests that are conducted without instrument. But today we are going to talk about the test on cement in the laboratory. So in the lab we are conducting fineness test of cement to know the fineness of cement. Second test is standard consistency of cement. Then setting time of cement, soundness test on cement, compressive strength on cement. So these are the various tests conducted on the cement. Now starting with the fineness test, as you know that cement is sieved through 90 micron ISU, and when it is sieved through 90 micron ISU, we should, that's the residue, should not be retained more than 10%. Okay, so we are taking 100 gram of sample and we are saving it for 10 to 15 minutes, and you should see what is the residue left over the 90 micron ISU, means particles more than 90 micron ISUs. So as per the IS requirement for OPC cement, it should not be more than 10% residue, and for rapid hardening cement it should not be more than 5% of cement retained on the sieves. So IS requirement here is 10% for OPC cement and 5% for rapid hardening cement. Means most of the particles are finer than 90 micron sieve. Rate of hydration process is mostly depends upon fineness of the cement. As the cement is more fine, so rate of hydration process will be faster because more surface area of cement is available for complete the hydration process. Now second test, we are going to discuss about standard consistency test of cement. So this test is normally conducted to know the water demand, exactly what is the amount of water to be added in the cement to make a good paste, or the paste prepared that should be very consistent. So to test this, we are using the plunger of we are using the wickets apparatus, using the plunger of 10 mm diameter and 50 centimeter length. That should penetrate 33 to 35 mm from top or 5 to 7 mm from bottom. So here whenever we are taking the cement sample, we are taking the cement sample. In that case, what we are doing? So we are adding water 20% initially, checking the penetration. We are adding 25% water, 27% water, 29% water, and the water quantity at which we are getting this particular penetration, that is 33 to 35 mm from top or 5 to 7 mm from bottom, that particular quantity of water called as the standard consistency of cement. And normally that water range is from 20 to 32%, or in most of the cases that consistency of UPC cement is around 30% to the total weight of cement. Now next practical is setting time test on cement. As you know that cement, when water is added into the cement, hydration process starts. And you know that the hydration, in the hydration process, most of the cement sets within 30 to 45 minutes. So whatever cement you are using for the construction, you must know that what is the setting time of particular type of cement, so that we can able to complete the various procedures like mixing for 5 to 10 minutes, then transporting for 5 to 10 minutes, then we are placing it, we are compacting it, we are finishing it. Means to complete all these operation from mixing to compaction, at least we may require around 30 minutes. So that's why this time is mostly set more than 30 minutes. Means initial setting time should not be less than 30 minutes. Again, to test this setting time, we are using the wicket apparatus. For initial setting time, we are using 1 mm square needle. Again, requirement of the reading is same, 33-35 mm from top or 5 to 7 mm from bottom when sample is prepared. And at the interval of 10 to 15 minutes, we should check the penetration of the needle in the wickets mold, exactly what is the penetration, and the time at which we are getting the reading 5 to 7 from bottom, that corresponding time will be the initial setting time. And around this time is mostly greater than 30 minutes, 30 minutes to 90 minutes also, it may vary, but it should not be less than 30 minutes, that is a requirement. Now to test the final setting time, we are using the needle of 5 mm square diameter at the tip point, and that reading is normally uh, taking after 10 hours, means 600 minutes. So whenever we are testing it for final setting time, that penetration, the needle should not penetrate into the sample, only impression of needle we should found on the particular sample, then we can say that that sample is finally set. Next test is soundness test of cement. So normally cement contain free lime magnesia that when reacts with water slowly, it increases its volume considerably. Sometimes this increase in volume or decrease in volume may cause the cracking, disintegration in the cement. So whatever cement we are using for concrete, that should be unsound, means there should not be any volume change. Whatever size we are preparing, that size should be retained after 24 hours. To check the sound net test, we are using the Leach Atelier apparatus. So that Leach Atelier apparatus is, you can see in the figure, it is having 30 mm diameter, 30 mm height, and there are two needle indicators having the length of 16.5. And when we are filling it with the cement sample, we are keeping two glass plates, one is at top, one is at bottom. By adding some weight on the top, we are keeping this assembly in the water for 24 hours, and after 24 hours remove the sample from the not remove, but we should see the distance between indicator, that should remain same whatever you are noticed in first day. If there is any change in reading in the indicators, it shows there is a presence of lime and magnesia, and we can say that there is a change in volume of the cement, and actually volume should not be changed. That is our requirement. Even sometimes because of temperature also there may be variation in the volume. So that's why sometimes this particular assembly is kept in water for 30 minutes, and it is boiled around to 100 degrees Celsius temperature. And when it is boiled for 100 degrees Celsius, again try to note down the reading between the indicators. If it is found same, then it should show that it is showing that there is a no free lime and magnesia present, and there is no volume changes recorded. So in this way we can check the soundness test. Now next practical is compressive strength test on cement. So specifically compressive strength of cement is different, compressive strength of concrete is different. In compressive strength of cement, we are casting a small size cube of 70 by 6 by 70 by 6 by 70 by 6 size, which is having area around 5000 square. So this test is normally conducted to know the strength of cement. Whatever cement we are purchasing from the market of 33 grade, 43 grade or 53 grade. So whenever, for example, if we have purchased 53 grade of cement, so we should get after 28 days the 53 MPa strength. In the laboratory we are verifying the same. Sometimes if it is urgent, then we are normally checking it for 3, 7 and 28 days, or even before that, to know the compressive strength of cement. Here what we did in this particular practical, we have casted 6 cubes of size 70 by 7 by 70.7. Area is around 5000 square, and after curing this for 28 days, we should check the strength under CTM, and we should see that exactly what is the compressive strength. If it is 53 grade of cement, then strength should be 50 more than 53 after 28 days of testing. Okay, so this is about the compressive strength of cement. So same thing I have shown here. Cube is casted in this figure. We can see it is cured in one of the tank and then tested under the compression testing machine. And if you see the graph over the age of the days and compressive strength, we'll see that as the duration means 3, 7, 28 increases, the strength of concrete is also increases. And to know the strength, we are taking just a ratio of load taken by the sample divided by area of the sample, that is area of the cube, and we are getting the strength. Now after the cement, next one is the test on aggregate. So we'll discuss about the test on aggregate. Now we'll discuss about the test on fine aggregate. On fine aggregate, we have conducted sieve analysis test to know the fineness modulus. We have also checked sand for bulking of sand, specific gravity test, water absorption test, and silt content test. So sieve analysis is normally conducted to know the gradation of the sand, fine aggregate. Gradation means what? Exactly what kind of particle or what is the grading of that particular particles. So to know the suitability of that particular sand sample in the concrete. So normally sieves arranged for fine aggregate starting from 4.75, 2.36, 1.18, 600 micron, 300 micron, 150 micron, and pan. Okay, so after doing the fineness that sieve analysis, we have to record the weight retained on each sieve. Then you have to find out the percentage weight retained, then cumulative weight retained, then summation of cumulative weight retained divided by 100, you will get the fineness modulus. For sand, fineness modulus range is normally from 2.2 to 3.2. If it is in between fine, if sand is very fine, the range is 2.2 to 2.6. Sand is, if it is medium, 2.6 to 2.9. Coarse sand, then it is 2.9 to 3.2. You can see here the different sizes of the sieve in the figure. And even in the concrete mix design, we need different zones of aggregate. Whether zone is 1, 2, 3, 4, 5, 4, like that. So normally zone 1 is a coarser sand and zone 4 is a fine sand. Now next practical we have conducted on fine aggregate, that is bulking. We know that normally sand and fine aggregates are stored in the open spaces. Many times it is caught moisture because of weathering action during night time, or sometimes there is a rain, because of that sand caught the moisture, and because of presence of moisture on the surface sand increases its volume. So bulking effect is normally due to presence of moisture, that moisture creating a short thin film around the particle which increases the size, and bulking is normally affecting your the proportion of concrete. If you are doing the volume batching, so this is not a good practice that you should use the bulk material. So in that case always you should go for the weight batching. Okay, material should be taken by the weight. Every material should be taken by the weight. If you are taking it by volume, because of bulking effect, that volume chosen may be wrong. So that's why uh, to exactly to know the percentage of bulking, so that we can add that extra material in the concrete mix, so we are conducting this particular test. You can see here, mm, uh, in the container, in one container there is a bulked sand, means which contains moisture, that is having the greater volume, that is capital H, and the saturated sand means what, it is full of water. When full of water, entire whites get reduced to zero, and we'll get only the saturated sand. Whenever we in the laboratory, how we have conducted this experiment, initially we have taken 500 to 600 gram of sample. We have added 2% weight, 2% moisture, 4%, 6%, 8%, and every time we have filled that sample into the cylinder, and we have noticed the increase in volume. So in the graph we can see initially at the uh, less percentages, when 0 to 4 is added moisture, then we got somewhat less bulking, but when we can see 5 to 6% water is added, we will getting the maximum bulking of sand. So that's why bulking effect should know, so that we can apply the correction in the material proportioning. Next one is the silt or clay content. So many times examiner is asking you the question, what are the good qualities of sand, or good qualities of fine aggregate. So good qualities means what? That sand should be free from silt and clay. That sand should not contain any sort of deleterious material. So many times sand contain much more mud particle, clay particle. Because of that, it affects the bonding between the materials. Cement and sand sample do not have the good bond because of presence of clay, and that's why strength gets reduced. So in the laboratory, we have tested this silt content or clay content with the help of jar. We have taken 500 to 600 gram of sample filled in the cylinder. Then we have washed that sample by keeping hand on the top side, and by washing it we have kept that particular cylinder aside for 2 to 3 hours. Sometimes to increase the settling rate of the particle, we are adding the sodium chloride, that is salt, in the water, so that that particle will settle earlier and will get the clay content. And that clay content should not be more than 5 to 10%. If it is more than 5 to 10%, such a sample should be rejected. So that is the IS requirement. Now next test is test on fresh concrete. So test on fresh concrete normally contain the workability, segregation and bleeding, or sometimes honeycombing. In the figure you can see the fresh concrete. To measure the workability, we are conducting slump test, compaction factor test, VB consistency meter test, flow test and Killigall test. Workability means what? The ease with which concrete can be mixed, transport, placed and compact. Till then it should remain in homogeneous state or isotropic state. So concrete should be consistent and it should have some flowability. So that is the requirement. That workability normally depends upon water cement ratio. If water is more added in the concrete, workability will increase, but you know that if you are adding more water to the concrete, it reduces the strength because of formation of maximum voids. So second, with the aggregate size, when particles are finer, then you need more water for the mixing, and sometimes workability may get reduced. Then aggregate shape, you know that rounded shape aggregates will give more workability than angular and cubical shape of aggregate. But as per the IS requirement for the concrete is conical angular aggregates around 20 size. That is the requirement of coarse aggregate. Workability also changes because of cement content. If cement content is more, we will get good workable concrete because more fine material is available for the mixing. Sometimes admixtures are added to improve the workability. Temperature is also affects the workability. Higher temperature reduces the workability. Lower temperature increases the workability. The first test in to test the workability is a slum cone test that is used in laboratory as well as on the field because of its simplicity. We have conducted this test in the laboratory with the help of slum cone of height 300 top diameter 100 and bottom diameter 200. And whenever we are preparing the concrete, we are filling that concrete sample into the mold, and when mold is lifted vertically upward, we are measuring the slum from the top of the particular top side. You can see in the figure that rod is kept horizontal and slum is measured from the top side. Okay, so top side means what? What is the magnitude of that collapse? That magnitude, or we can say height, is measured. In the figure, you can see three types of slums. One is a true slum, means only small slum value between 50 to 100 that is accepted. Second one is shear slum, means one side is collapse, one side is as it is. Third one is the collapse slum, means what? When concrete contains more water, that particular concrete spreads on the entire concrete spreads on the surface, that is collapse slum. And zero slum means what? Whatever shape of cone is there, same is obtained for the concrete. When concrete is having very less water, at that time you are getting the zero slum. But as per the IS, we should not get the zero slum. At least there should be uh, concrete should have some slum value, maybe 50 to 100 So according to the slum value, from 0 to if slum value 0 to 25, it is called as a zero. We can say it is not workable concrete. For low workable concrete, slum value ranges between 25 to 50 For medium workability concrete, slum value ranges between 50 to 100 and for higher workability, it is greater than 100 The next practical conducted to test the workability is uh, compaction factor test. So this test is very accurate, considered as a very accurate test because it handles very dry weight as well, very dry concrete as well as very wet concrete containing more water. In case of slum, what happen? If concrete is dry, we are getting the zero slum, and when concrete is having more water, we are getting the collapse slum. But that limitation is overcome in this particular compaction test. That's why this is considered as a very accurate test, compaction factor test. Here, how that compaction factor is determined? Here we are taking the ratio of weight of partially compacted concrete to weight of fully compacted concrete. Here you can observe the three buckets. Whenever concrete is prepared, we are adding in the top bucket, then opening the trap door of upper bucket, allow the concrete to fall in middle bucket. Then we are opening the middle bucket hopper, and then allowing the concrete to fall into the cylinder. By leveling the cylinder, we are taking the weight without any compaction. That weight is called as a partially compacted concrete. And then by empty that particular cylinder in the tray and again fill with full compaction, and that weight is taken as a W2. That is the fully compacted weight, and the ratio of partially compacted to fully compacted, we are getting the compaction factor value. And then when that value or that ratio is more than around 0.95, we can say that concrete is having higher workability. If that ratio is around 0.90, we are saying it is having the medium workability. That ratio is 0.8 to 0.85, we can say low workability, and less than 0.8 or around 0.75, it is called as the zero workability concrete or very less workability concrete. Next test conducted to test the workability is flow table test. So in this case, what we are doing, we are filling the cone. This size of cone is 12 centimeter height and 170, 250 diameter at bottom, 170 at a, 120 at a top, 250 at a bottom, and height is around 170 That is filled with the concrete, and then by removing the cone, 15 jolts are given. Jolt means what? That impacts. 15 uh, jolts are given in 15 seconds, and that height of drop is 12.5 when we are giving the 15 jolt, what happened? That concrete spreads over this particular top, and then you have to measure the, with the help of scale, you have to measure the spread in centimeters. So and then percentage flow is determined. Spread diameter in centimeter minus 25 divided by 25 multiplied by 100, and that flow value should be in between 0 to 150%. Okay, so that is the requirement. In this way we are conducting the workability of concrete using the various tests in the laboratory. Similarly, we are having another two tests, that is Curie ball test and VP consistometer test, to check the workability. Now coming to the properties of hardened concrete, you know that once to know the exact strength of the concrete, in the laboratory we are conducting destructive test, or in the field we are conducting non-destructive test. In the lab we are having compressive strength test, flexural strength test, and split tensile test. Whereas non-destructive test are rebound hammer test, ultrasonic pulse velocity method, and impact echo test. So destructive test means where we are casting beam, cylinders, and cubes, and we are breaking it with the help of CTM, UTM. That's why it is called as a destructive test. But destructive tests are very accurate compared to non-destructive. Non-destructive tests are considered as the approximate method. That results may not be correct, or may not be 100% correct. Results are correct, but surety of correction is around 90 to 95. Not we can say it is 100% correct. So the NDT tests are normally conducted during the audit, structural audit of the structures, then quality check, third party checks, where with the help of electronic instrument we are checking the test of concrete, that is called as the non-destructive test. Normally non-destructive tests are called as a very quick test. So they within 5 to 10 minutes we are conducting rebound hammer test, ultrasonic pulse velocity method, or impact echo test. That's why NDTs are very popular nowadays, because of its simplicity in use and quick results. In destructive test we have to wait for 28 days to get the results, and even when we are casting the beam, cube, cylinders, we need material sample, cement, sand, aggregate, means it is costly, whereas non-destructive tests are not much costly. So that's why it is normally used for the existing structures also. Whenever you want to demolish any old building, so structural audits are carried out with the help of non-destructive testing. So first of all, we'll discuss about the destructive test. In that we are these tests are normally conducted on the concrete. Okay, so cubes of 15 by 15 by 15 centimeter, that is 150 150 150 are casted. They are cured for 28 days, and after 28 days they are tested with the help of CTM, and then strength of that particular cube is measured. The strength is normally depends upon the grade of concrete. If you are casted M20 grade of concrete, so after 28 days you should get strength more than 20 MPa. If you are casting a concrete of grade M50, that is M50 grade, then you should get the strength more than 50 MPa after 28 days. So this particular table at the bottom shows the strength gain over the days. If you are casting the cube in one day, it gets 16% strength. Yeah, after 3 days we are getting 40% strength. After 7 days we are getting 65% of strength. After 14 days we are getting the 90% strength, and after 28 days we are getting the 100% strength. So that's why this is called as the one of the accurate test to know the grade of concrete. Second is the flexure test on concrete. You know that concrete is weak in flexure and tension, but sometimes it is subjected to some sort of flexure material. Flexure means what? Bending. So concrete should have some ability to take the load in bending. So in our laboratory, what we did, we have casted this beam of 100 by 100 by 500 mm. We have cured it for 28 days, and then after 28 days, we have carried out the 2-point load test. That 2-point load test is called as the test of pure bending, where we are getting the pure bending test. And to know the value of FCR, that is a flexural strength, we are using the formula PL upon BD square. So this is abbreviated equation derived from flexural equation, that is M upon I sigma by Y E by R, that you have studied in strength of material. And as per IS 456, the flexural strength of the concrete should be around 0.7 root FCK. 0.7 into root FCK. Under root of FCK means what? FCK is the grade of concrete. If it is M20 grade, then FCK will be M20. FCK will be 20. So to know the flexural strength of M20 grade of concrete, it is 0.7 under root of 20. You will get the flexural strength. So this test we have conducted in laboratory to know the flexural strength of concrete. Next test is indirect split tensile strength on concrete. We know that uh, concrete is weak in tension, but sometimes it is subjected to uh, tension directly, indirectly. So that's why you should know that exactly what is the tensile capacity of that particular concrete. In that case, to check that, we have casted a cylinder of 150 mm diameter and 300 mm length, and that is we have tested it using CTM by keeping it in horizontal and by applying load on the circumference. So that's why to know the value of indirect tensile strength, we are using the formula 2P upon pi LD by using pi DL or pi LD, both are same. So we are checking the indirect tensile strength of concrete. So in the hardened category, three tests are important: compressive strength, tensile strength, and indirect split tensile strength and flexural strength. And now non-destructive test. You know that non-destructive tests are conducted without any destruction to the concrete or without breaking the concrete sample. So uh, that's why these tests are very fast, economical, and normally used for the audits. So in that we have in our laboratory we have used rebound hammer test. It is very simple test to know the hardness of hardness of particular concrete. We are getting the rebound number uh, of particular concrete, and rebound hammer can be used in horizontal, vertical, and downward position as shown in the figure. On the right side, you can see the rebound hammer. Within 5 minutes we are getting this reading. uh, for the rebound hammer, at least you should take 5 to 6 reading at different locations of the cube or structure, and then it take its average reading so that your result will be accurate. Next test we have conducted is ultrasonic pulse velocity method. So this is it is normally called as UPV in actual practice, that is ultrasonic pulse velocity. Here the velocity transmission through the concrete is measured. There are three methods. One is direct transmission, another is direct transmission, another is semi-direct transmission, and indirect transmission. This test is accurate compared to rebound hammer test, because here uh, waves are transmitted through from one side, and another side there is a receiver which receives the that particular velocity, and receives the particular frequency, and then we calculating the velocity distance upon time, and based on the velocity we are deciding the quality of concrete. So in this table you can see when pulse velocity is more than 4.5 kilometer per second, that concrete quality is called the excellent quality. When that pulse velocity is greater than around 3.5 to 4.5, that concrete quality is a good quality concrete. And likewise we can see the concrete quality with the help of ultrasonic pulse velocity method. Then we have also visited RMC plant to know the its operation, to understand the batching mixing of the concrete. That's why uh, the RMC visit is very important to understand the different concepts. Nowadays RMC plant or RMC concrete is very popular because um, we can speed up your construction work. We can assure the good quality concrete. Even we can use the admixtures in control form to get the good quality of concrete. Mainly uh, in in cities, we are not having the place to stack the material on the road or anywhere. That's why nowadays this particular RMC concretes are very popular. That visit we have already given to one plant, and examiner may ask you around RMC and its advantages, disadvantages, like that. So now prepare well for all the practicals. Examiner may ask you different practical questions also. Exactly what is going on the site. So you should have the knowledge of concrete very well during your oral. Whenever you are discussing anything, question may arise from the discussion only. So do prepare very well. Try to avoid the wrong answers. If you don't know the answer, keep mum and say sorry, sir. I can ask me different questions like that, but don't answer any in a wrong way so that further questions will not come. So in this way, I have tried to cover all the particular points in this particular presentation. So best of luck for your oral. Thank you very much for your patience listening. So thank you.